So the curve C with equation y equals p minus 3x all over 2x minus q multiplied by x plus 3, where p and q are constants, passes through the point x equals 3 and y equals a half, and has two vertical asymptotes with equation x equals 2 and x equals minus 3. In the first part of A, we need to explain why you can deduce that q equals 4. The key bit of information is that we have two vertical asymptotes. Now you get vertical asymptotes when the denominator equals 0, because if you try dividing by 0 you can't, so it creates asymptotes. This means there are vertical asymptotes when the denominator equals 0, so in this case the denominator is 2x minus q multiplied by x plus 3, and that equals 0. So this means that 2x minus q equals 0, or x plus 3 equals 0. So that means here that x equals minus 3, or 2x equals q. So we can see here in the question that we've got x equals minus 3 here, and x equals minus 3 here, so we sorted that. The only one we haven't sorted is x equals 2. So we know that that one must be related to this right here. So what I'm going to do is just sub x equals 2 into this right here. So we're going to have 2 multiplied by 2 equals q. So therefore, q equals 4 as needed. So now A part 2 says we need to show that p equals 15. So in the previous part we worked out what q equals. So I'm just quickly going to rewrite out the equation for curve C right here, but replacing q with 4. So doing that, we get y equals p minus 3x all over, and we get 2x minus 4, because we're replacing the q with 4, multiplied by x plus 3. Now, a key bit of information in the question is that the curve C passes through the points x equals 3 and y equals a half. So what I'm going to do is sub in x equals 3 and y equals a half into the equation of curve C. So doing that, we're going to get that a half equals p minus 3. So x here is 3, so multiplied by 3, all over. That's going to be 2 multiplied by 3 minus 4, multiplied by 3 plus 3. So evaluating these brackets, we'll get, okay, so that's 3 times 2 is 6 minus 4, so we get 2. And that'll be 6. So times by 6 equals 12. So if I rewrite that out here, we get p minus 9 all over 12. So I'm just going to move over here for our final working. So far we've got that half equals p minus 9 all over 12. So if we times both sides by 12, we're going to get 6 equals p minus 9. So therefore p equals 6 plus 9, just by adding 9 to both sides. So therefore p equals 15 as needed. Fantastic. So looking through to see where we get the marks. We get 1 mark up here for all this working. So essentially explaining that 2x minus q equals 0 when x equals 2, which then means that q would equal 4. So we get 1 mark for that. And then we get 1 mark down here for realising that we need to sub in the points 3 and a half to make sure we've just got p as the single unknown. And then we get the final mark here for then using our algebraic manipulation skills to work down through to show that p equals 15. So we're now going to work through part B. So figure 4 shows a sketch of part of the curve C, and the region R, shown shaded in figure 4, is bound by the curve, the x-axis, and the line with equation x equals 3. Part B says we show that the exact value of the area of R is a, the natural log of 2, plus b of the natural log of 3, where a and b are rational constants to be found. And this is for 8 marks. The first thing I want to do is work out what this point is, because we're going to integrate between x equals 3, but we need to know our upper limit of integration. What's great is in the previous part we worked out what q and what p equals. So now we can write out the equation of the curve C, replacing p and q with the values that they are. So this is the equation of the curve C, where we've replaced q with 4 and p equals 15. So now to work out this point here, this is actually the x-intercept, so we're just going to set y equal to 0. So we're going to have 0 equals 15 minus 3x all over 2x minus 4 multiplied by x plus 3. And if we times both sides by the denominator, we're going to get that 0 equals 15 minus 3x. So 3x equals 15. So x equals 5. So that's great. We've got our first bit of information that we need to know. That this point right here is x equals 5. So essentially, to answer the question, we're going to need to integrate between x equals 3 and x equals 5. And we're going to be integrating the curve C. So we're going to be integrating 15 minus 3x over 2x minus 4 multiplied by x plus 3 with respect to x. So to integrate this, we're going to need to use partial fractions. So we're now going to work on writing this equation in partial fractions. So we're going to say that 15 minus 3x all over 2x minus 4 multiplied by x plus 3. So we've got something a over, and we're going to have 2x minus 4 here. And then we're going to add on to that b over x plus 3. So now our job now is to work out what a and b are. So what we're going to do, we're going to multiply both sides through by the denominator here. So this means it cancels out here, so we just get 15 minus 3x. And these brackets will cancel, so we'll just get a multiplied by x plus 3. And these brackets will cancel here, so we'll just get b multiplied by 2x minus 4. So now we're almost there working out what a and b are. So we're going to take a couple of steps. Firstly, I'm going to let x. And firstly, I want to try and work out what b is first. So we want to try and work out a way to get rid of a. Well, to get rid of it, if you times it by 0, you're going to get rid of it. So we're going to let x equals minus 3, which will mean that this bracket goes to 0, which means we're just left with b and we can solve for b. So here we're going to get 24, because if we sub the x equals minus 3 into here, we get 15 minus 3 times by minus 3, which gives us 24. And then this bracket just goes down to 0, so we can ignore that. And that's going to equal b multiplied by, so 2 times minus 3 is minus 6. And if we take away 4 from that, it goes to minus 10. So therefore b equals minus 2.4. And here we're just going to do the same thing again, but we're going to get rid of b this time so we can work out what a is. So we want this bracket to go to 0. That means we need 2x minus 4 to equal 0. So that means x is going to need to equal 2. So we're going to let x equals 2. So if we sub that into the left-hand side, we're going to get 15 minus 6. So we're going to get 9 equals, and the b gets eliminated because we're just multiplying it by 0. So the a, we're going to have 3 plus 2. So we're going to have 5a. Therefore, a equals 9 divided by 5, which is 1.8. So here I've just written out the partial fractions a bit neater, using our values for a and b that we worked out earlier. So all that's left to do is work out the area of the region R. So we're going to do some integration. So we're going to integrate between, and like we worked out earlier, we've got between x equals 3 and x equals 5 here. So 3 here and 5 there. And we're integrating this curve here, but instead of writing it in this form, we're going to write it in the partial fraction form here. So we've got 1.8 over 2x minus 4 minus 2.4 over x plus 3. And we're going to integrate that with respect to x. Now, one of the rules of integration we can use is that if we're integrating something which is in the form of f dash of x over f of x with respect to x, that will equal the natural log of the modulus of f of x plus c. Now we can use this rule up here for integrating both these terms. For example, for this one here, if we say f of x equals the denominator, so 2x minus 4, f dash of x, so when we differentiate it, will just be 2. Now, we see we've got 2 here, we've got 1.8 here. However, that's not too much of an issue. We can work around that. We just need to work out what multiplier we need to use to get from one to the other. So if we do 1.8 divided by 2, we get 0.9. So we're going to use that as a multiplier to get from one to the other. I'm going to do this for the other one quickly, and then it will make sense what we mean in a second. So for this one, we've got f of x equals x plus 3, and f dash of x equals, so that would just equal 1 when we differentiate. But on the top, we've got 2.4. So what I'm going to do is, again, 2.4 divided by 1. Well, that just equals 2.4. So we're going to use that as a multiplier. So when we integrate it, so this term is going to become, we're going to need to use our multiplier first. So 0.9 multiplied by natural log of 2x minus 4. I'm going to add on to that, integrating this term. And we need to remember we've got the minus sign here. So instead of the plus here, we're going to have minus, and then we're going to have 2.4, so I'll multiply from down here, multiplied by the natural log of x plus 3. And we need to remember our limits of integration, so between 3 and 5. Just quickly want to explain why we've got these multipliers here. So if we imagine we were just differentiating this, we can use the rule we have for integration, but in reverse. So if we're differentiating this, we'll get this. So this means if we just differentiated the natural log of 2x minus 4, we get 2 over 2x minus 4. However, that's not what we want. We want 1.8 over 2x minus 4. So we need to times that by the multiplier 0.9. So if we include the multiplier, we get 1.8 over 2x minus 4 as we need. Great, so lastly, we're just going to evaluate this by subbing in x equals 5 and x equals 3. So we're going to get 0.9 natural log of 2 multiplied by 5 minus 4 minus 2.4 multiplied by the natural log of 5 plus 3. And then we're going to subtract from that. And I'm going to put some brackets in because we're subtracting all of this. 0.9 multiplied by the natural log of 2, and this time multiplied by 3 minus 4, minus 2.4 multiplied by the natural log of 3 plus 3. So tidying this up a little, we'll get 0.9. And then inside the modulus sign here, we'll get 2 times by 5, so that's 10 minus 4, so we get 6. Minus 2.4. And then we get 5 plus 3, so that's 8. And we're going to subtract. And we're going to subtract both terms here. So we're going to get minus 0.9, the natural log. And evaluating this, we get 2 times 3. So that's 6 minus 4, so we get 2. And then because it's a negative times a negative, we get plus 2.4. And the natural log of 6. So we can combine both these terms quickly. So we'll have 0.9 plus 2.4, which equals 3.3. Minus 2.4, ln 8, minus 0.9, ln 2. Right, so now we're almost there, but if we look back up at the question, we see we need to write it in a form where we've only got log of 2 and log of 3. So we've got to manipulate this a little bit more. Well, using some of our log laws, we can say actually this is 3.3. Ln 6 is actually the same as ln 3 plus ln 2. Because the rule is you can multiply these together when you're adding them to combine it into one log, and 3 times 2 is 6. And we've got minus 2.4 ln, and 8 we can actually write as 2 to the power of 3 minus 0.9 ln 2. So first I'm going to multiply out this bracket, so we get 3.3 ln 3 plus 3.3 ln 2. And then here we can use the log law to say we're going to bring down this power and multiply it by the minus 2.4. So doing that, we'll get minus 2.4 multiplied by 3, so minus 7.2. So ln 2. Then minus 0.9 ln 2. So lastly here, we're just going to collect like terms. So we're going to have the 3.3 ln 3. Then we're going to collect all of the ln 2's together. So 3.3 minus 7.2 minus 0.9, which is going to be minus 4.8 ln 2. And that's actually the final answer in the correct form that they wanted. So looking through to see where we get the 8 marks for this question. We get 2 marks here for working through the partial fractions. So work out that we need to do partial fractions and setting up like this and trying to find values for A and B. We get another mark for partial fractions here, so for working out the correct values for A and B and writing out in this form. Then we essentially get 4 marks for the rest of our working here. So integrating successfully and subbing in x equals 5 and x equals 3 and using our log laws to get down to the correct form. And then we get our 8th and final mark for this line here, so correctly identifying there will be 3.3 as the coefficient of ln of 3 and minus 4.8 of the coefficient of ln of 2.